Functions, page 1. Maybe you're looking at your book, page 54. You can follow along there or just follow along here. In your life, what are two numerical quantities that a relation might relate? Okay, so like something I was looking at the other day was the relationship between the dollar and the Brazilian real. So like, for example, $1 maps to 3.6 reais, something like that. And if I had $2, that would map to 7.2 Brazilian reais, for example, and so on. A domain of a function of a relation relates values of variables on the x-axis to the range values of variables on the y-axis. Remember domain and range from a couple of years ago? Y-axis, okay. A relation is any set of points which connect x to y. Okay. Label the quadrants of the Cartesian plane from the right to the right from first through fourth. Okay, so we got, 1, 2, 3, 4. Okay. Another name for a function is a mapping. What characteristic does a function have that a relation does not? Every function is a relation, but not every relation is a function. What a function has that a relation does not have is that every x only maps to one y. Okay. Every x maps to one and only one y. Okay. Describe in detail one of the methods to find out if a relation is a function. For example, there is the vertical line test, where you draw a vertical line through the function, through the relation, to show that the line crosses the function through one and only one point. If it does cross 2 points, the relation is not a function. Okay? Okay, on a graph, what is the meaning of filled-in circle, empty circle, and arrowhead? Okay, maybe this is something you've seen before. But whenever you have a graph, you might extend the graph to infinity, and that would look like an arrow. Okay. Maybe the graph is not continuous, and so you have a line, vertical line here, dotted line. And here, the value that the graph takes on is like this one here. Let's say it's 3. But then when it continues to the right, we'll say this is 1, it is discontinuous. It drops a little bit. And so the filled-in circle says, hey, this value, which is like -3, is 3, not 1. Okay, so the open circle shows that at -3, the function does not exist. At 3, the function does exist. Okay, so those are the meanings of filled-in circle, empty circle, and arrowhead. Okay. Which of the following sets of ordered pairs are functions? We're going to look through here for like any kind of repetition. So, like for example, here we have 1, 3, 2, 4, 3, 5, and 4, 6. That looks good. No repeats. Okay. Okay, and then what about the next one? 2, -1, 2, 0, 2, 3. Uh-oh. Lots of repeats here. So like here, not okay, because lots of repeats. Okay, not okay, because x equals 2 maps to more than 1. Why? Okay. What about B? Or what about E? This looks good. 0 maps to 0, 1 maps to 0, 3 maps to 0, 5 maps to 0. Y is repeated, but that's okay. Okay. B. We got 1 maps to 3, 3 maps to 2, 1 maps to 7, -1 maps to 4. All those are fine too. All the x's are mapping to just one y. The same x is not mapping to 2 y's. And the next one, that looks fine too. And, oops, here's one that doesn't look good. Look, I have like everything, all the zeros are mapping to 4 different numbers. So, D is okay, and F I put not okay because x equals 0 maps to 4 different numbers. Okay? Moving on to page 2. Use the vertical line test to determine which of the following relations are functions. Okay. So let's see, I'm going to put several vertical lines through, and it looks fine. Right? I'm only crossing the function at one point each time I cross through with the vertical line. Looks fine too. Uh-oh. No. Right? I crossed here and I crossed here. Looks fine. Uh-oh. Look at that. 2 times. Okay? This looks fine. This looks fine. Even if I cross right at the dot, do you see how like some of the dots are, oh, wait a second, look at that. Uh-oh. Look at that. If I cross here, there are 2 dots, one on top of each other, so no. This one here is okay, you see that? Because there's a black one and a white one, colored and not colored in, but not all of them are like that. So this looks fine too. Okay. Alright. That wasn't too hard, was it? Now, will the graph of a straight line always be a function? Give evidence to support your answer. Well, most straight lines are functions. There is one straight line that is not, and that is the straight line that is vertical. Because look, what if you did like the Vertical line test on a vertical line. Oh my gosh, look at all those intersections. So, will the graph of a straight line always be a function? No, because vertical lines are not functions. Okay. Give algebraic evidence to show that the relation x squared plus y squared equals 9 is not a function. If you remember back from previous class, x squared plus y squared equals 9 is a circle with a radius of 3. Okay, the radius squared is the 9. So, let's say you got a circle that kind of looks like this. Okay, and obviously it does not pass the vertical line test. But not only that, if we want to give algebraic evidence, we could put in a certain number. Like we could say that, hey, look, at the point x equals 0, I have two different y's. I have 3 and negative 3. And I'll show you here. I'll say 0, x squared with 0, x is 0. And then if I put y as 3, I get 9, right? And then if I put negative 3, I also get 9. So there's two solutions here. There's a positive 3 and negative 3 are two solutions for y for one value of x. So we proved that it's not a function, right? That's like doing the vertical line test right here. All right? So that's it for page 2.